Hello everyone, I am CH Lokesh. In this presentation, I am going to tell about programmable logic devices. So, programmable logic devices. Programmable logic devices help in digital logic implementation by allowing designers and developers to create custom logic functions without using many individual gates, reducing circuit complexity. They also provide flexibility, enabling easy modification or reprogramming of logic as needed. So if we want to design a logic circuit and we try to make it with by using gates, it will it will be very big circuit and very complex circuit. But if we use PLDs, it will be very simple and we can reprogram them. I mean, we can use them for another purpose also. Introduction Introduction about PLDs. PLDs are three main types: PROM, PAL, and PLA. PROM stands for Programmable Read-Only Memory. PAL stands for Programmable Array Logic, and PLA stands for Programmable Logic Array, each differing in how their and OR arrays are programmed. PROM stores fixed logic, PAL allows programmable AND logic, and PLA provides full flexibility with both and OR arrays programmable. So, what is a PLD? A PLD, a programmable logic, is useful in real-world designs because it allows circuits to be customized, modified, or upgraded without changing the hardware, saving time and cost. It also enables faster development, higher flexibility, and easier debugging, making it ideal for modern electronics like controllers, communication devices, and embedded systems. So now we are going to look about PROM, Programmable Read-Only Memory. So PROM is a type of memory chip that can be programmed only once by the user to store permanent data. It contains a fixed AND array and a programmable OR array, allowing it to act like a lookup table for implementing simple logic functions. So in this PROM, we have a fixed AND array and a programmable OR array. So that means we can program the OR array, we can change the connections of OR array. The connections of OR array are fused connections, but whereas the connections of AND array are fixed. So we can change the connections of array, but we can change the connections of the OR array. So the structure of PROM is like this. So we can clearly see that here the connections of the AND array are fixed, but whereas the connections of R array are fused. The cross symbol means the connections are fused, where the complete solder means the connections are fixed. So this is a complex diagram, and for simplicity, the diagram can be drawn like this. So PROM has a fixed AND array and a programmable OR array. This is fixed AND array, and this is the programmable OR array, where data is stored by blowing fuses. So these cross marks are fuses, and we can store data by blowing these fuses. So this is almost like a decoder. We can simply see that. So for this is for a 2 input. This circuit acts like a 2 by 4 decoder. So it generates all the minterms, like how decoder will generate all the minterms. So we can use the decoder circuit instead of all of this stuff. So the decoder selects memory locations by activating one unique line for each input combination, allowing the stored output to be read. So the working of PROM. The address selects a word and stored data represents logic function outputs. PROM gives outputs by using the input bits as an address to look up a stored value in its memory cells. For each address, the corresponding pre-programmed output is fetched and sent to the output lines. And so we all are already familiar with the working of decoder, and it's same like the decoder. The advantages of PROM: it is very easy to program and high flexibility for lookup tables. So PROM is great for fixed lookup tables and simple functions. The limitations of PROM: cannot change AND array. Yeah, we have already discussed that in the structure of PROM, that we have seen the fixed connections of AND array. So we cannot change AND array. Not suitable for complex logic reductions. So now we are going to look about the PAL. PAL stands for Programmable Array Logic. So the name itself tells that it has programmable AND array and fixed OR array. So a PAL is a PLD, programmable logic device, that has programmable AND array and a fixed OR array to implement logic functions. It allows designers to create custom Boolean expressions efficiently with good speed and simplicity. The basic structure of PAL: it has multiple gates, multiple AND gates with fuses, fixed OR gate connections. So in the next slide, we're going to see the structure of the programmable array logic. This is the structure of programmable array logic. PAL has a programmable AND array. You can clearly see that the connections are according to our uses. We can change these connections according to our Boolean expression or our particular operation. So the PAL has a programmable AND array, and where required product terms are created. The product terms are created here, and a fixed OR array. And we can see the OR array is fixed here, that combines those terms to form outputs. The structure makes PAL simpler and faster, but slightly less reliable than PLA. So the PLA we are going to discuss is in the next slides, but here this is the programmable AND array, and this is the fixed OR array. The working of programmable array logic. Programmable array logic works by generating required product terms through its programmable AND array based on how the fuses are set. These product terms are then combined by the fixed OR array to produce the final output logic functions. Advantages of PAL. PAL is faster than PROM and more optimized than PROM. PALs work faster and support simplified implementations. The limitations of programmable array logic. So we have seen that the OR array is not programmable in PAL, and it is less flexible than programmable logic array. So now we are going to learn about PLA. The definition: PLA stands for Programmable Logic Array, and unlike PROM and PAL, PLA has both and OR arrays are programmable. So the PLA where both and OR arrays are programmable, allowing full customization of logic functions. It provides maximum flexibility for implementing complex digital circuits. And the structure of PLA has both customizable and R arrays. It is more flexible than PROM and PAL. Here is the basic structure of PLA. So we can see the fused connections of R array and the AND array also. Actually, the here should be also these fused connections, but unfortunately there was a dot. So assume that there are here also the fused connections are here. So with the PLA contains the programmable AND array and also a programmable R array that let us create complex outputs. The structure offers good speed and good flexibility for implementing more hard logic functions. Working of PLA. So user-defined product terms or array maps functions independently. In PLA, each output function is independent because both the and or array are programmable, allowing any function to be formed without restrictions. PLA optimizes logic by sharing common product terms between functions, reducing the number of gates and simplifying the overall circuit. The advantages of PLA: it has highest flexibility and it is efficient for complex logic designs. So PLA's full programmability makes it suitable for complex circuits. And the limitations of PLA. PLA as it contains both programmable arrays, it is costlier and it is slower. And the programming of PLA is a bit complex than other two. So the table shows the comparison bit among the PROM, PAL, PLD. So we can see that again. The full form of PROM is programmable read-only memory, and PAL is programmable array logic, and PLD is programmable logic array. So we can only program PROM once only, but in PAL programmable AND array, it has programmable AND array and fixed OR array. In PLD, both are programmable. Yeah, in PROM, we have it has fixed AND array and programmable OR array. In programmable array logic, it has programmable AND array and fixed OR array. In PLD, it has programmable AND array, also programmable OR array. Uh, PROM is used as a lookup table to store fixed outputs for each input combination. PL is used to implement medium complexity logic with good speed, and PLD is used to implement complex and highly flexible custom logic functions. And this is the comparison among these three type of PL programmable logic devices. So actually this is PLA programmable logic array, and the flexibility, speed and cost differences also vary among these three. The flexibility of PROM is very less and it has moderate flexibility, and PLA has very high flexibility. Cost differences, the PROM is very less costlier than the both of them. Applications of PLDs. So the PLDs are used in CPUs, controllers, embedded systems, and many digital logic circuits. So conclusion. So to the conclusion of PLDs, the PROM, PAL, PLA. Programmable logic devices allow digital circuits to be implemented flexibly and effect efficiently without using many individual gates. PROM works like a lookup table with fixed and programmable arrays, giving outputs based on stored memory values. PAL uses a programmable AND array and fixed array, offering fast and simple logic implementation. PLA provides full flexibility with programmable and OR arrays, enabling independent functions and optimized logic by sharing product terms. Overall, PLDs make real-world designers easier to modify, faster to develop, and more efficient to implement. Thank you.